I hope you're doing well. Today we're looking at IEB's May 2024 paper 1 and we're focusing on question 10a. The picture below shows the roads that link town A, town B, town C, town D and town E. Okay, so the question is, if you start at town A, how many different ways could you drive to town E? Okay, so let's see what's going on here. Let's just, I'm not sure how to tackle this one, but I'm just going to first play around with ideas. Okay, I think I kind of know what's going to happen now. So yeah, how did I guess that? So, okay, it's a question of almost like permutations. There are three ways to get from town A to town B. It's either you take this road, this road, this road. So that would be, if we think about the number of slots that need to be filled in, we're trying to go from A through B, C, D, and then E. So there are 5 slots that need to be filled. Yeah, so we need to say, okay, how many A's can I pick? How many roads that come out of A can I pick? And that's 3 of them. And then we look at the next one, B. There are 4 roads that join B with C. So that means there are 4 options. After we've chosen, this guy, we can then choose this guy, this guy, this guy, or that guy to be our second, the second leg of our adventure. Okay, and then similarly, town C only has 2 roads coming out of it to connect to D. So there are 2 options for roads coming from C. And then lastly, I made a mistake. It's not 5 slots, it's 4. It's 4 because this is leg 1, leg 2, leg 3, leg 4. Okay, anyway. So for the last one, D has 1, 2, 3, 4, 5. There are 5 different roads coming from D that end up at E. Right. So what we can do is to just times these together, right? And it's because of, let's just think about this, just considering this and not the fuller picture, but once we have the smaller picture, we'll be able to anticipate what happens with the bigger question. Remember that this is really just a question asking you, let me get some color in here. So here's road number 1 from A to B. This is road number 2, and this is road number 3, right? So if we just look at town A to town C, how many different routes could get us from A to C? And the logic there is you could start here and then go here, 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 or here, right? So that's 4 possibilities. Or you could start here and then 1, 2, 3, 4 possibilities again. Or you could start here again and also have 4 options for your second leg. So just on a smaller scale, this is what this calculation is doing. It's saying that for every starting route, starting leg, there's going to be 4 options for what must follow that leg. And because we have 3 options for how to start the journey, that means that the number of possible permutations here is 3 times 4, which is 12. Okay, so let's come back to this bombastic equation here. So 3 times 4 is 12, times 2 times 5 is 120. So there are 120 ways that we can go from town A to town E. Right, next question says, oh boy, oh okay. So we're still dealing with the context from the previous question. We're now looking at number 2. The traffic police set up 3 roadblocks, 1 between town A and town B, 1 between town B and town C, and 1 between town C and town D. What is the probability that you'll go through at least 1 roadblock if you travel from A to E? Okay, so let's see where the roadblocks are. So there's one roadblock between town A and town B. So there's no real reason, like you could have chosen this one or this one as well. There's no significance attached to which road you choose to be the one with the roadblock. It's just as long as it's a road between town A and town B. Okay, and then we have another another roadblock between town B and town C. And like I said earlier, it doesn't matter which one you choose as long as one of them we know has a roadblock. And one between town C and town D. Okay, so there's the other roadblock. Okay, and then we're asked, what is the probability that you'll go through at least one roadblock if you travel from town A to town E? Okay, so at least one roadblock means you could experience more than just the one. So for example, if you look at this route, right, that route goes through all the roadblocks. So right, and we know that when we hear at least, the probability of at least blah blah blah, it's so much easier to just use the complementary, the complement here. Yeah, so let's say over here specifically we want to say there's at least one roadblock that gets encountered. That will be the same as 1 minus the probability that 0 roadblocks are zero road, the driver does not go through any. What does that even mean, guys? Okay, just a disclaimer, I am feeling unwell and a part of me feels like I should just call it quits here because it's just getting crazier and crazier. Okay, but yes, in order to determine the probability of encountering at least one roadblock, and that would be a lot of counting because you'd have to consider this route again, but now I go to the second E route, this route again, and then so it would be so tedious to manually count it. So we can use the complement, which says that the probability of getting at least one roadblock, the opposite of that is to get no roadblocks at all. So yeah, you're either in a situation where you don't encounter any roadblocks, or you're in a situation where you encounter at least one roadblock. Those two events are mutually exclusive, and they are exhaustive. They exhaust the space of possibilities. Okay, so how do we work out probability of 0 roadblocks? Well, let's see. We know that. Okay, let me just write here. I'm not going to do the probability calculation yet. I'm just going to count how many roads qualify. Oh, this is also interesting because no, that's fine. Okay, number of ways for us not to bump into roadblocks. Okay, so that is going to be from town A to town B, there are 2 options. From town B to town C, there are 3 options. From town C to town D, there's only 1 option left. And then from there, we have 5 last legs that we can choose. And that comes to 60. So, and then the question is, okay, how big is the sample space? How many routes are possible? And we worked that out before. We worked that out to be 120. Right? And so the probability of at least one roadblock will be equal to, I'm pretty much rewriting this, honestly. Let me just rub it out. Yeah. Oh, golly. Okay, so that will be 1 minus 60 over 120, which is a half. Okay, so the chances of encountering at least one speed roadblock is a half. It's a 50-50. So don't take the chance. Okay, let's see if the memo agrees. I always get so nervous about counting. Where art thou, answer? Okay, so we got the first question right. That is exciting. Yay. And then, yeah, okay, the second one is a disaster. Disaster, because that is not what I got. Oh no. Oh, sorry. Yeah, I was just trying to figure out where I went wrong. That is where I went wrong. So the answer here is actually 30. Sorry. So then, that'll be 1 minus 30 over 120, which is the same as a quarter. So this will be 1 minus a quarter, which will be equal to 3/4. So the probability of encountering at least one roadblock is actually more significant than I had calculated before. There's a 75% chance that you're going to encounter at least one roadblock on your travels from A to E. The memo also has a tree diagram as another approach. So let's check that out, how we construct a tree diagram for this. We'd say, okay, we're starting from town A and we're going to town B. And the only thing we care about in drawing our tree diagram is whether that road has a roadblock or not. So starting from A, it's either I'm going to encounter a roadblock or I'm not going to encounter a roadblock, right? So now we look to town B to say, okay, what is the chance of encountering a roadblock? And they tell us that it's the chances of bumping into a traffic cop is going to be a third. So to not bump into I'm writing this the wrong way. The probability of not encountering the speed block is, what am I doing? Okay, right. So then now off to the next. So we look at C, and we're told that there's one roadblock between town B and town C, and they have 4 paths between them. So again, we're going to use so we're going to, I need to move this down. This is what always gets me with tree diagrams. It just requires so much space. So from here, I could either encounter a roadblock or not encounter a roadblock. And likewise here, you could either encounter a roadblock or not. So if we look at our diagram, right, we just mentioned that there are 1, 2, 3, 4 routes that one can take from B to C, and there's one speed block on one of them. So the chances over here of encountering a roadblock is a quarter, and here it is 3/4, and it will be similar there as well. Okay, and then are we almost there? Okay, almost there. So now the next one we look at is from town C to town D. There are two options. One of them has a roadblock, so let's draw that in. So either we have a roadblock or we don't. Oh, run out of space so bad. Okay, so chances of encountering a roadblock is a half, 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 half. Okay, and then now we are finally at the last stretch. So for this one though, none of the rows have a speed block, so we don't have to put in a complement of r because that will be 0. So let me just write that out so that it's clearer. So we could bump into a roadblock. I mean, we can't because there is no roadblock, but for the sake of completion, let's just pretend I'm not smoking socks. Yeah, these R's are looking so funky, man. Okay. Yeah, I'm just gonna, because I'm running out of space here, I'm just gonna illustrate the point again. So the chances of from town D to town E we encounter a roadblock is 0 because there are no roadblocks on that leg of the journey. So the probability here would be 0, and the probability, no, not, sorry, yeah, 0, sorry. And the probability of not encountering a speed block on that road or any of those roads is 100% because we've been told there are no speed blocks there. So you could even stop the tree here because we're just going to have probabilities of 0 and 1, 0 and 1, and that's not going to change anything back here. So that's 1. That's also 1. Yep. Okay, last few. Okay, so now what we are interested in is, okay, I'm not gonna write down for each of our intersections what is happening. Okay, so so to use the tree diagram to answer the question, you could go and manually count all the routes where there is at least one speed block. So you could say there's this one, so that's a roadblock, no roadblock. So that would be one option. Another option would be no roadblock, perhaps, no roadblock, and then I hit a roadblock here, and then no roadblock. So that's another example where you have, I forgot my train of thought. Okay, what am I doing? Okay, so again, the simplest way would be to calculate the complement. So you would say 1 minus, and then look for the route where there are no roadblocks, right? So that would be, so it's definitely not along this half of the tree because already we're starting out with someone, I don't know what I'm saying. Okay, so this part of the tree is cancelled, right? Because the very first road already has a speed block, so we're not going there. Okay, so now it will be this guy, and another no roadblock, and another no roadblock, and that. So that would be the one. Yeah, and that is the only one really. So it would then be 1 minus 2 over 3, because these are independent events, so we can just times their probabilities together. So that is 1 minus a quarter, which is indeed 3 over 4. So that's also a nice way to go about this question. Okay, thanks for tuning in. Thanks for bearing with me on my very foggy head day. My brain is just so kaput. Anyway, cheers.